review the inverse derivative stuff. So if we take the derivative of this, what is the derivative of sine of an angle?
Negative, or cosine.
Yeah. It's hard going back and forth from derivatives and antiderivatives, isn't it? So it's the cosine of the sine inverse of x times the derivative of the sine inverse of x, and the derivative of x is 1. All right? So from there, we get that the derivative of the sine inverse of x is 1 over the cosine of the sine inverse of x. Now, do y'all remember from first semester what we did from there to set the rest of this up? No. If you don't remember, that's fine. I was just seeing if y'all remember. All right. We drew a triangle that had a sine of x. So we're going to draw a triangle in the first quadrant that has a sine of x. So that would be the opposite over the hypotenuse, which would mean that the bottom leg of the right triangle would be 1 minus x squared, the square root of it. So the cosine is 1 minus x squared, the square root of 1 minus x squared over 1, so we just say it's the square root of 1 minus x squared. So that is the derivative of sine of x. Well, guess what here?
Why is the derivative of inverse sine x 1 over cosine times sine inverse x? Why is it chain rule there? Or I don't even know what rule that is, but why is it?
What? All right. The derivative of sine of an angle is the cosine of the angle.
Yeah. Yes, sir.
Times the derivative of that angle. Well, we don't know what the derivative of sine inverse of x is, so we just have to write the derivative of sine inverse of x.
Yes,
And that just so happens to be what we're wanting to solve for.
Okay, why does sine inverse x equal 1 over cosine times sine inverse x?
This is the cosine of the sine inverse of x. It's not the cosine times.
Oh, okay. Well, then
So
why does
I
it
want to
equal
know, have I answered your question?
No.
Okay. All right, is it from this step to this step or this step to this step that you got a question about?
I guess the second to the third.
Second to the third, okay. So what happens is, I'm trying to get this by itself.
Mm-hmm.
So I divide both sides by this. So I divide by the cosine of the sine inverse of x.
Mm-hmm. Okay, I got it.
All right, now I want to understand what the cosine of the sine inverse of x is. So I have to draw a triangle that has a sine of x.
Mm.
So that's the bottom leg. So what's the cosine of this triangle?
Mm.
Well, it's the square root of 1 minus x squared over 1. So I just write it as that.
Sure.
Does that help?
Mm-hmm.
Okay. So what would be the antiderivative then of what is the antiderivative? What had this as a derivative?
Cosine, 1 over cosine,
Mm-mm.
cosine of sine inverse x.
The sine inverse of x. If the derivative of the sine inverse of x is equal to this, that the antiderivative of this would equal to that. Does this make sense?
Yes.
Okay. Any other question here? All right. Well, I want to get into an example problem dealing with this real quick. So let's just say I want the derivative, I want the antiderivative of 1 over the square root of 4 minus x squared dx. Well, the trick with this is I need for this number right here to be 1. And this number right here is not 1, right? So I have to do a little bit of maneuvering with this. So I've got 1 over, all right, so this would be the square root of 4 times 1 minus. Okay, so when I factor out a 4 from x squared, it becomes a 2, right? So it's x over 2 quantity squared. Does that make sense? No. Okay. Well,
Yeah, why isn't it x over
distribute
4?
back in and see what happens. If I distribute 4 into that parenthesis, I've got 4 times 1, right?
Mm-hmm.
Which is 4. All right, so what is x over 2 if I square it?
X squared over 4.
It's x squared over 4, and then what's 4 times x squared over 4?
X squared.
Just x squared.
Jeepers Christ.
I couldn't have said it better myself.
And we did
Okay.
that just to get a 1 under there.
We gotta have 1 here. We gotta have 1
The
here.
other thing doesn't matter as long as there's just 1 there.
Well, I wouldn't go that far, but because,
Oh, okay.
all right, now, what is the square root of 4?
2.
2. Okay. So I've got 1 over 2 times the square root of 1 minus x over 2 squared, which would be 1/2 of the integral of 1 minus x over 2 squared dx. Square root of that, sorry.
Yeah,
That's vaguely important. All right. Now, this there is no guessing on what I want u to be, because it has to be in the form of 1 over the square root of 1 minus u squared du. So there's no, okay, do I let u equal to 1 minus this or whatever? No, u has to equal to x over 2. So that makes this a little bit easier, the fact that we don't have to guess what we want u to be. So what would du be?
du.
1/2 dx, right? Good? So 2 du equals dx. So I have 2 over 2. This 2 right here comes out here to the numerator. So now this is 1 minus u squared du. So that's going to equal to the sine inverse. Oh, that almost looks like the integral of n. All right, that was lame. I'll try not to use that joke again. So this becomes the sine inverse of u plus a constant. And now, again, this is a indefinite integral problem. So we get to substitute that back in, so it's equal to the sine inverse of x over 2 plus c. Is there a question about that?
Debbie, move.
Yeah, or you could move.
We have to move and stuff.
Mhm.
So would we just be expected to like memorize the inverse side, like the inverse trig functions?
You need to know the inverse trig functions. Be very familiar with them. On the AP test, one, maybe two questions on this. Not really a make or break deal, but going on in calculus, you need to recognize this for the purposes of anti-differentiation. All right. So, likewise, if this had ended up being negative, then we could say it was the cosine inverse. But generally speaking, we will write the negative of the sine inverse before we write the positive of cosine inverse. It's just kind of how that happens. Okay, so do you remember what the inverse of tangent is?
I can find it. Oh, of tangent? I was thinking it's
I don't need that.
the derivative of the inverse.
The derivative of the inverse of tangent. It was 1 plus 1 over x squared, or you could say 1 over x squared plus 1. All right. So, here I am. In case y'all don't see me here. I've got dx over 9 plus 4x squared. Okay. Now, a couple things happen in here. One of the things that's happening here is, if I'm giving you this problem, I'm not going to say solve using inverse trig functions. So you look at that and your first instinct may be, hey, let's try u substitution. Well, if I let u equal to the denominator here, I don't have an 8x or any form like that in the numerator. So the u substitution directly like that's going to fail. Well, then I might say, okay, well, let me try long division. Well, if you try long division with this, you're going to see that this would end up being, you would have 0 plus this as a remainder. So that wouldn't work. So typically, inverse trig is not going to be your initial try here. But I do need it in the form of 1 plus something. So, what do I need to do to make this become a, or factor out of 9, right? Okay. So I have 1 plus. Now, what do I get when I factor 9 out of 4x squared?
2x over 3.
Yeah. 2/3 x squared. Okay, let me pull my 1/9 out front. All right, so what would I want u to equal to here? Well, there's only one option.
1 plus 2/3.
gotta be in this form of,
2/3 x.
yeah, just a 2/3 x squared. Just 2/3 x, sorry. Not 2/3 x squared, but 2/3 x. Come on in. All right, so, what would du equal?
2/3 dx.
So, 3/2 du equals dx, right?
Yes.
Okay. So I'll pull the 3/2 out front, so it's 1/9 times 3/2 times the integral of one over one plus u squared du. And that is 1/6 of the integral of, no, not the integral anymore. It's times the tangent inverse of u plus c, correct? Which is 1/6 of the tangent inverse of, and what is u again?
2/3 x.
And it doesn't matter where you put the plus c, you can put the plus c in the parentheses with the tangent inverse, so, let me just write it like this. And we're good.